we discuss hybridization. We see some example molecules: ammonia, water molecule, PCl3, PCl5, and phosphine. Let us find hybridization in ammonia molecule. We have a formula to find hybridization in a simple manner. First, we have to find lone pair of electrons in this molecule. How to find lone pair of electrons? The formula is number of lone pairs is equal to group number of central atom, that is our nitrogen, minus number of sigma bonds in ammonia plus number of pi bonds in ammonia by 2. After finding the lone pair of electrons, we can find hybridization from this formula. Hybridization is equal to number of lone pair of electrons plus number of sigma bonds. If we get 3, it is sp2. If we get 2, it is sp. If we get 4, this is sp3. If we get 5, sp3d. If we get 6, sp3d2. Likewise, you can find the hybridization. Now we see ammonia molecule. Roughly we can draw this as nitrogen attached to 3 hydrogens. So find the lone pair of electrons by this formula. Lone pair of electrons is equal to group number of nitrogen is 5, number of sigma bonds 3 sigma bonds, 1, 2 and 3. There is no pi bonds, so 0 pi bonds by 2. We got 1 lone pair of electrons. Now we can find hybridization from this formula. Lone pairs plus sigma bonds. Lone pairs 1, sigma bonds 3. We get 4. So its hybridization is sp3. And how to know shape of ammonia molecule? If sp3 hybridization is there, if 1 lone pair of electron is present in a molecule, that is pyramidal. This is governed by Vesper theory, that is valence shell electron pair repulsion theory. So ammonia molecule is sp3 hybridization and pyramidal structure. Let us see hybridization and shaping. Now we find hybridization and shape of water molecule, H2O molecule. We will find lone pairs by this formula. Lone pairs is equal to group number of central atom is oxygen, its group number is 6, minus sigma bonds. We draw a rough diagram of water molecule. So we got 2 sigma bonds and we have no pi bonds by 2. We got 2 lone pair of electrons. And how to know hybridization? From this formula, lone pairs plus sigma bonds. 2 lone pairs and sigma bonds 2. That is 4. If it is 4, it will be sp3 hybridization. And how do we find shape? In sp3 hybridization, if 2 lone pairs are present, shape will be V shape. This is also called bent shape. So V shape and sp3 hybridization for water molecule. Now we find hybridization for PCl3 molecule. Now we calculate lone pair of electrons from this formula. Group number of phosphorus 5, sigma bonds. To find sigma bonds and pi bonds, we draw a rough diagram of PCl3. So we have 3 sigma bonds and no pi bonds. 1 lone pair we will obtain from this formula. How to find hybridization? Is lone pairs plus sigma bonds. 1 lone pairs plus 3 sigma bonds, that is 4. If we get 4, this will be sp3 hybridization. And as per valence shell electron pair repulsion theory, if a molecule has sp3 hybridization and 1 lone pair of electrons, its shape will be pyramidal, just like in ammonia as we discussed previously. And we will try to find hybridization and shape in PCl5. Now first we will find lone pair of electrons. Lone pairs is equal to group number of phosphorus minus. To find sigma bonds, we will draw a rough diagram of PCl5. So sigma bonds will be 5, pi bonds, no pi bonds, by 2 we get 0 lone pairs. And how to find hybridization? As per this formula, hybridization is lone pairs plus sigma bonds, 0 lone pairs, and 5 sigma bonds, sp3 dehybridization. What is the shape of this PCl5 molecule? If any compound has sp3 dehybridization, it is trigonal bipyramid. How this trigonal bipyramid will be? Phosphorus, Cl, Cl, Cl. This is trigonal. Or bipyramid means above the plane, below the plane there will be one chlorine atom. This is rough structure just to find out the number of sigma bonds and pi bonds. This is the actual structure. This is trigonal bipyramid. Now we will find hybridization in pH3 molecule. pH3 molecule. First we will find lone pairs, group number of central atom, minus sigma bonds, 3 sigma bonds, no pi bonds. To find sigma bonds, we have to draw a rough structure like this, and you can calculate sigma bonds from here. There are no pi bonds. We will get one lone pair. Hybridization is sigma bonds plus lone pair of electrons. This lone pair of electrons is 1, sigma bonds 3, we will get 4. If you get 4, hybridization will be sp3. And shape will be, for sp3 hybridization, if one lone pair of electron is existing, that will be pyramidal shape. How this pyramidal shape will be? This will be phosphorus, H, H, H. Here will be lone pair of electron. This will be pyramidal shape. Let us find hybridization in SF6 molecule. Each fluorine can form 1 sigma bond, so totally 6 sigma bonds will be there. First we will find lone pair of electrons, group number of central atom, minus sigma bonds, number of pi bonds by 2. And to find hybridization, lone pair of electrons plus sigma bonds. Let us calculate lone pairs in SF6. Group number of sulfur is 6, sigma bonds 6, there are no pi bonds by 2, so there is no even one lone pair of electron. And find the hybridization, lone pairs plus sigma bonds, 6 sigma bonds, it will be 6. If you get 6, the hybridization will be sp3 d2. And what is the shape? If sp3 d2 hybridization is there and there are no lone pair of electrons, that will be octahedral structure. How the structure will be? Sulfur, like this, it will be octahedral structure. Let us find the hybridization IF7. Find lone pair of electrons, group number of iodine is 7, 7 sigma bonds, 0 pi bonds by 2. We will get 0 lone pairs. And hybridization will be lone pairs plus sigma bonds, 0 lone pairs, 7 sigma bonds, we will get 7. If you get 7, that will be sp3 d3. And shape will be, if sp3 d3 is there, its shape will be pentagonal bipyramid structure. How the pentagonal bipyramid will be? Iodine, fluorine, this will be pentagonal bipyramid structure. And let us find the hybridization BeCl2. Find lone pair of electrons, group number of beryllium, second group, sigma bonds 2, no pi bonds, we will get 0 lone pair of electrons. And hybridization will be lone pair of electrons plus sigma bonds. If we get 2, it will be sp hybridization. If we get 3, it will be sp3 hybridization. So for any sp hybridization, Shape will be linear. That means beryllium will be like this, linear structure. Let us find the hybridization in BCl3 molecule. For finding BCl3 molecule hybridization, find lone pair of electrons, group number 3, sigma bonds 3, no pi bonds by 2, we will get 0 lone pair of electrons. Hybridization will be lone pair C plus sigma bonds, 0 plus 3, that is 3. If we get 3, we will get sp2 hybridization. Shape will be, for sp2 hybridization, 0 lone pair of electrons. Shape will be trigonal planar. That will be like this. Trigonal planar structure. Let us find hybridization in CH4. Let us find hybridization in CH4. First find lone pair of electrons, carbon group number 4, sigma bonds 4, pi bonds 0 by 2. How do you find sigma bonds? Each hydrogen atom will form single bond with carbon. So 4 hydrogens, they form 4 sigma bonds. We will get 0 lone pair of electrons. And to find hybridization, we have to add lone pair of electrons in sigma bonds. Lone pair 0, sigma bonds 4 will get sp3. And shape for sp3 hybridization with 0 lone pair of electrons will be tetrahedral. How this tetrahedral structure will be? This is the tetrahedral structure. So, using this formula, we can find the hybridization shape in very easy manner.